We are now going to learn more about weight, which is a special form of gravitational force. Can you still define gravitational force? Gravitational force is the attraction force that any two objects exert on each other because of their mass. But we are specifically going to look at the gravitational attraction force between a planet, such as the Earth, and an object that is on or near the planet, because both objects have mass. This gravitational attraction force that a planet exerts on an object that is on its surface or close to the planet is always downward towards the center of the planet and is known as weight. But what is the difference? Gravitational force is between all objects on each other that have mass, and it acts in all directions. Weight is the gravitational attraction force that a planet exerts on an object, and it is always downward. Weight is defined as the gravitational force with which the Earth or any other planet attract objects on or close to them. The symbol for weight is W, and the unit still is Newton, because it is a force. Weight, in other words, the strength of the attraction force of the Earth on an object like the man or on the crate, can be determined with the Newton spring balance. To differentiate between the weight of the man and the weight of the crate, we make use of footnotes. Can you still define mass? Mass is a measurement of the amount of matter that an object consists of. I do hope that you still remember the symbol and the SI unit of mass. The symbol is M, and the SI unit of mass is kilogram. Mass can be determined with a mass meter, or what we call a scale. Let us apply this knowledge. An astronaut stands on a scale that measures his weight in Newton on the Earth before he departs, and then again on the Moon as soon as he lands there. Once again, we use footnotes to indicate with which weight we are working. He sees that his weight on Earth is much more than what it is on the Moon. Can you explain this? It is the same person, so his mass stayed the same. The weight of the astronaut differs because the gravitational attraction force of the Earth on the astronaut is different to the gravitational attraction force of the Moon on the astronaut. The mass of the Earth is much more than the mass of the Moon. Therefore, is the gravitational attraction force of the Earth on the astronaut much more than the gravitational attraction force of the Moon on the astronaut. The weight of the astronaut is the gravitational attraction force on the astronaut on a specific place, and therefore will the weight of the astronaut on the Earth be more than what it is on the Moon. If you have your weight, you can determine your mass, or if you have your mass, you can determine your weight by using this equation. W is weight in Newton. Some textbooks use F footnote G. M is mass in kilogram. If the mass is given in gram, you must convert it to kilogram. Can you convert 8 gram to kilogram? 1000 gram is 1 kilogram. Therefore, will 8 gram be equal to 8 divided by 1000? In other words, 0,008 kilogram. Can you write this in the scientific notation? 8 times 10 to the minus 3 kilogram. You can also use this method. 1 gram is 10 to the minus 3 kilogram. Therefore, 8 gram is 8 times 10 to the minus 3 kilogram. G is the gravitational acceleration that is measured in meters per second squared, and it is always towards the center of the Earth, which means downward. Gravitational acceleration says how fast you accelerate towards the planet, that also means the Earth, if only the gravitational force of the planet is acting in on you. The value of G differs from planet to planet and is determined by the mass of the planet and the distance that you are from the center of the planet. The value of G for a specific situation will be given to you, but you must know that on Earth it is 9,8 meters per second squared. Before we do any calculations, we must first discuss the scientific method. This method must be used for all problem solvings, irrespective of the grade you are in. We will do it by way of an example. Read the question carefully. Pete's weight on the moon is 176 Newton. Calculate Pete's mass if the gravitational acceleration of the moon is 1,6 meters per second squared. Remember that Pete's mass is a constant value, irrespective of where Pete is in the universe, but that his weight is determined by the gravitational acceleration of the place where he is. Represent the problem with a sketch. Pete on the moon. Write down all the information, also that which is asked, in symbol form onto the sketch. Remember that footnotes help you to know what you are working with. Firstly, Pete's weight is given. Mass must be calculated, so it is our unknown. Gravitational acceleration on the moon is also given. Now you are ready to write down the correct equation that contains all the symbols. Footnotes will help you to substitute the correct values, because sometimes you work with different weights, masses and accelerations. Remember that an equation can only have one unknown, and that is the quantity that is asked for. Now you can substitute the values that you have into the equation. Only then may you make the unknown quantity the subject of the equation, if needed. Do the calculation. You must answer the question. Pete's mass is 110 kilogram. For your answer to be complete, the unit of that which you calculated must be included. Even if a problem is quite simple, you must follow all the steps. Get used to doing it this way, because each step earns marks, and this is the way it will be marked in the exams. If you only write the answer, you will only get 1 mark. Equation, substitution, change the subject, answer with a unit. To summarize, you must know the following definitions. Weight, the gravitational attraction force with which the Earth or other planets attract objects that are on or near them. Mass, a measure of the amount of matter that an object consists of. Weight is measured in Newton and changes as the gravitational attraction force on the object changes. The SI unit for mass is kilogram, and the mass of an object never changes. Weight and mass can be calculated with this equation. In the next video, we're going to solve more problems by applying the scientific method. Work through that before you write the test.